optical path. Next topic. And what this optical path means, we have considered one light ray, which is, tell me now, where the speed of the light is more, in a medium or in air?
Air.
Air's, the speed of the light is more, isn't it? Now, so let us consider, we have taken some medium, we have taken. This is some medium. And this medium having some refractive index. Having refractive index is mu. Let us say the distance of this medium, this part which is equal to d. Now let us say this light ray which is traveling from here to here. For the light ray to travel to here, it will take some time, right? So can you tell me now how much the time taken by the light ray to move from, yes, this much distance, A to B, let us say D distance, the time taken, if I call this as a T1, tell me now how much the T1? Time taken by the light ray to move from, to travel this much of distance of D. So T1 which will be equal to what we can say now? Equal to distance by speed now. And what is the speed, you tell me now? D by speed in any medium is given by C by mu. So we'll come
Yes,
to
sir.
as what element of mu D by C. Okay. This is the time taken by the light ray to travel D distance in a medium. Okay. Now I made the same light ray to travel in air now. Same light ray I made to travel in air. Okay. Now here the medium is air. In the same time, of t, I want to get it as how much the distance the light ray will travel. I want to find out what element of distance traveled by the light ray in the time t I want to get. So that should be, if I call this distance, if I call it as a something x, if I call, tell me now how much the distance is equal to what, tell me now. So speed into time. Speed is how much now? The medium is 8 now. 8. Velocity speed is how much now? C. In a time of what,
Yes,
tell
sir.
me now? Same time of this much of time. Same time. Then x will come to be what, tell me now? C into t value. How much you tell me now? That is mu d by c. From this, what will come now here? C is mu d. So what is this x is? Where this x is called it as an optical path. X is called it as what, tell me? Optical path. Understood?
Yes, sir.
Read the statement now. Now you will understand easily. Optical path. Optical path means the distance traveled by the light in vacuum. In the same time, it travels in a medium. Okay. So obviously, where the light ray will travel more distance, the medium will travel or air will travel.
Sir, air.
Air will travel. So that distance is called it as an optical path. ठीक है?
Yes, sir.
Yeah. Now here this optical path we have seen now here, and so we should call it as an optical path difference also. Optical path difference. What is the optical path difference? Means the difference between these two is called as an optical path difference. Hmm. Right. So we used to call it as optical path difference. Optical path difference means these two difference. Optical path difference. And we should call this as delta x. And which will be given as what terminal. How much the distance it will travel in air is mu d. In a medium is what terminal d. Then we have delta x is equal to mu minus 1 into d. This is optical path difference. Delta x is called as a optical path difference. So initial path minus final path. So we have taken one light ray is traveled to the medium, other light ray travels to the air. The difference in the length is there now. That is difference in the length is called as a optical path difference. Right? Yeah. Now let's see some points here. So optical path length is given by mu into d na. So obviously optical path length which is always greater than the actual path. Here mu is what, tell me? We have seen the optical path. So this is x is equal to what, tell me now? Mu into d. What the mu is a refractive index. Refractive index which is always greater than or equal to 1. So that's why which is greater, d greater or x greater, which is greater? Yeah, here in this x and d, which is greater value, bigger value? Yeah, so that's what, where x is called it as what, tell me now? X is optical path. X is optical path length, and the d is called as a original path length, actual path. In this, which is greater, you tell me now, optical path is greater than the original path, right? Yeah, so this thing. Now, so for example, one light ray will travel in time t travels a distance d1 in a medium of refractive index mu1 and d2 in another medium having refractive index is mu2. Then the relation between them which is given as mu1 d1 equal to mu2 d2. Mu1 d1 equal to mu2 d2. Okay. Optical path in the first medium is how much? Mu1 d1. Optical path in the second medium is how much? Mu2 d2. Those both must be equal. Same time na? Both must be equal. Mu1 d1 equal to mu2 d2. right? Now, optical path difference. Optical path difference delta X, delta we have seen now, and which will be equal to what element now? Optical path minus actual path, which will be given as mu minus 1 into d. This is the optical path. Next. So in this case, so let us see next one what we have taken now. We have taken the two parallel rays traveling in a medium of refractive index mu1. One of the ray passes through a parallel glass slab of thickness d. Refractive index of that medium is mu2. Then they are asking to find the path difference in this case. So path difference means the distance between those two. So, and so here the first ray, so if I call this as optical path in the first one, which will come to be what, tell me now, this is mu1 into d. Okay, first medium. And second one, optical path, which will becomes what, tell me. So here in this case, what they're saying here, so we have one medium is there. This is my medium. This medium refractive index of this complete medium is mu1. Inside there is one glass slab is there. Some glass slab, and this refractive index is given as mu2. Okay. Now one light ray which is passing from here to here, this much distance, d distance. This is the one light ray. Other light ray is passing here. Now in this case, what we need to do here, tell me now, this is light ray 1 and the second, this is the second light ray. The distance is d from here to here. Okay. Now this optical path of this light ray is that medium refractive index mu1 into d. And this optical path which will be equal to what we can say now here, this much. In these cases, we need to talk about the relative we need to see. Whenever if we place now here, whatever we wish to say, refractive index of some glass we wish to say, which is equal to 4 by 3, that is with respect to what? Air. Okay, now here this is placed in some other medium having refractive index is mu1. Right. So in this case, what we'll write now here in this case, we'll write it as what element now this one? This is mu2. This is what you tell me now. Mu2. This optical path will becomes what you tell me now. Mu2 into D will come or not? Right now here we need the optical path difference means delta x, that will be given as x2 minus x1. So that is delta x, which will be given as mu2 into d minus mu1 into d. So this delta x, which will come to be a, what we can say now here. If we have taken this as a d common and mu1 also common, we have taken this mu1 d, we have taken common, then it will come to be a what element now? Mu2 by mu1 minus 1 will come now. By mu1 minus 1 will come. So Then mu2 by mu1 is called as a relative refractive index, which is called as what, tell me now? Relative refractive index, mu2 by mu1. So that is delta x, which will come to be what, tell me now? Mu1 into d. This is called as a refractive index of 2 with respect to 1 minus 1. Okay. Yeah. Done. Whenever there is a two mediums are there, we need to take it as what, tell me now? A relative refractive index we need to consider. Not- Look, what? Then, yes. Now, see this problem. Consider slabs of three media. So we have three mediums are there, A, B, C, arranged like this. They given a refractive index of A is given 1.5, C given 1.4. If the number of waves in A is equal to number of waves in the combination of B and C, then they are asking to find the refractive index of B. Okay, now first of all, number of waves means, so if we have a wave means sine wave. So look at now here. So this one, sine wave, you might be known of this thing. Yeah, so this is called as one wave. This is called as one wave. Okay. So here, this is the positive part, positive cycle we should call. This is the negative cycle we'll call. A combination of positive and negative cycle, which is called as a wave. Right. And here, from here to here, this is called it as a wavelength, lambda. This point to this point, this length is called as a wavelength. Wavelength, you know now? Wherever it is started, we have to come back to same situation that is called as a wavelength. Right. Now you tell me now, for example, if we have the wave is there like this. Now you tell me now how much the wavelength you tell me now here. So this is lambda, and from here to here, this is another lambda. Okay. So you tell me now here, how many waves are there here? How many waves are there in this? Hmm? So here, look at now from here to here, this part up to here, this is called as one wave. Okay, it's a combination of positive cycle plus negative cycle is called as one wave. Here we have this is the positive cycle again. This is the negative cycle and below the x-axis negative cycle, above x-axis positive cycle. Now, how many waves are there in this case? How many waves are there? So from here to here, this is one wave, and this is the another wave. Now, how many waves are there? Two waves are there. In this case, how many waves are there? Two waves are there. If we call this length, so tell me now here. So this is almost the total length. 2 lambda. That means if we have a 2 lambda means we have two waves. 1 lambda means one wave. 10 lambda means 10 waves. Okay, fine. Now here, if I call this distance is something like as a generally distance is d distance, can you tell me now number of waves formula? The total distance is d. If I say the number of waves equal to what? Tell me now here. D by lambda. Yes or no? Here the how much the d value? Tell me. D is the 2 lambda. So that means number of waves. Number of waves. So if I call this as n, which is equal to what? Tell me now. Total distance by lambda is called as a number of waves. Understood how the formula developed? So now you see this thing here. So number of waves means total distance by lambda wavelength. Yeah, look at now here in this case. Now, so number what they given now number of waves in A equal to what I mean number of waves the combination of B and C. So if I call the number of waves in A is NA, which is equal to what is saying here the number of waves in combination of B and C, that is NB plus NC, isn't it? Now tell me now NA, the number of waves in A, how many? Tell me now. Number of waves, that means total distance now. How much distance you tell me now? From here to here, how much the distance is there? Whether am I audible? Hello? Am I audible? Yeah, your voice is not audible. Your voice is not audible. Yeah, tell me now NA. NA means what? Number of waves in A. Tell me the number of waves in A. How much the distance? Tell me. What is NA value? NA now. 1.5 is what? Refractive index now. We need number of waves, right? Number of waves formula is what? Tell me now. D by lambda. How much the A distance? Slab A distance. Length is how much? Hmm? Slab A this distance distance here? How much is meant? How much? Yeah, tell me. How much is NA value? NA means what? Tell me now. Distance by wavelength. Na? How much the distance? How much the distance? A distance means now this part is the A distance or not A length. Yes, so that is what you tell me now 3x by lambda. Wavelength in this medium. Na? Wavelength in this medium we can say this as lambda A. And what is the wavelength in any medium? That is lambda equal to what? Tell me now. Lambda naught by refractive index. Na? Lambda naught is what? Tell me now. Refractive index in air. So that means how much will come? You tell me now. This is 3x by lambda A means what we can say now here. Lambda naught by mu. Okay. That is mu means refractive index of A. So tell me now here. Refractive index of A is how much? 1.5. So that is 3 into we can say now this is 1.5x by lambda naught. Okay.
Yes,
See the number of waves in A. Now let's find the number of waves in B and C also. Tell me the number of waves in B. And how much the B distance?
X.
Yeah, so that is x by, we can write as what lambda B. Na? That is x by, we can write it as lambda naught by refractive index in B of B. So we will come to the what element of mu B into x by lambda naught. Okay.
Yes.
Mu B value given? Not given. We have to find.
No, sir.
Next, NC, tell me now. NC, it is
2x by lambda.
2x by lambda c. Tell me now. So this is 2x by lambda c is how much? Yes, 1.4. So you can simplify now here. This is 2.8x by lambda naught. What did I say now? What did I say here? NA equal to, that is NB plus NC, they are saying, and we can simplify. Now, NA value we got it as, so this is 3 into 1.5, which will be equal to 3x. So we'll come it as what element of 4.5x by lambda naught. 5x by lambda naught, which is equal to NB, that is mu B x by lambda naught plus 2.8x by lambda naught. Now simplify this thing. So x by lambda naught will get cancelled. So we'll come it as what now? 4.5. Yes, so UB plus 2.8. How much is mu B refractive index of second medium? 1.7. Okay. Like this, we need to do this one. Okay.
Yes.
Next one. A light beam is traveling from region 1 to region 4 as shown in the figure. So, and they given a refractive index of 1, 2, 3, 4 given as like this. The angle of incidence theta for which the beam just misses entering the region 4. Mhm. So, so have you heard about the critical angle?
Yes.
Yeah, critical angle. So we'll discuss the critical angle as of now. See this thing. Now what they're saying here, the light ray should not enter into the region 4. So it should be lies only on the surface only, should not come. So this light ray will go. So let us say this light ray which is coming like this, and thereafter it is going like this. And but the light ray should not enter into fourth medium, it has to go like this only. Okay. The angle of incidence for which the beam just misses the region 4, should not enter into region 4. Okay. So for this case, what will be the angle we need to find? Yes. Now here we draw a normal. So if we draw a normal here, yes. So now here you see this thing here, this medium, this is the angle. So here this is the, we're talking about only the directly region 1 and the region 4 will move. Intermediate not required also. Okay. Now this is the angle of incidence is theta. This is the angle of refraction. How much is angle of refraction in this case? Yes, so this R which will be equal to 90 degrees. That's it. Understood this point? Now you can apply Snell's law now. Yeah, tell me the Snell's law. So tell me now this medium 1 and medium 4 directly. Medium 1 the refractive index is a naught. So what is Snell's law? You tell me now. Mu1 into sine I equal to what? Tell me now. Mu2 into sine I. Mu1 means what? Tell me now. N naught into sine I. That is theta, which is equal to mu2 means what we can say now. N naught by 8 into sine R. R is how much now? 90 degrees. N naught will get cancelled. So that means sine theta, which will come to be what element of here 1 by 8. That means theta equal to, so that is sine inverse of 1 by 8. Okay. Lateral shift. Next one, lateral shift. Lateral shift means, consider we have taken some glass slab we have taken, and this having a some thickness is T. right? So let us consider a ray of light which is falling. Now I'm taking here, it is a normal, this is a normal, this is a normal. Consider a ray of light which is falling here. Okay. Now, so initially this is the air medium and this is some glass. So this is having a refractive index is mu. That means the light ray traveling from where to where, rarer to denser. So in this case, how the light ray will bend? How the light ray will bend towards or away to the normal. So this is the light ray actually, yes, it want to go like this. This is the light ray want to go like this. Because of this, the light ray will get deviated from its original path. Let us say the light ray which is deviated like this. Something. Right. Now, this is the refracted ray. Now, this refracted ray which is incidenting, yeah. And again, you have drawn a normal at that location. Right. Now, again, this light ray which is now moving from the medium to the air again. So again here this medium is what I mean now. Again this is air. It will come out from the glass slab. So again now the light ray moving from way to way, now denser to rarer. Now in this case light ray moving from way to way, denser to rarer. So that means how should we now, the light ray will bend towards or away. Yes, so this light ray which will move like this, finally the light ray which is coming, that light ray is parallel to the ray coming out, previous ray, incident ray. Okay, so here this and these two lights will appear as a parallel rays. Understood what I am saying? Now, what we need now here is, now there is some distance between these two rays. When these are coming out, we have a distance is there. This one, this is called as lateral shift. This much shift will, light ray actually has to go like this white line. But because of the slab, instead of going, that light ray is parallel to initial ray, but there is a shift is happening. This much of shift is there now. The shift is called as a lateral shift. Okay. Yeah. Here, if we talk about these points, now this point is A, and this point I'm calling this as a B. So if I call this is now OA, and this is AB, and this is BC if I call. Okay. Now, and this is a N is a normal, this is also normal. Now this OA, what is OA is called? OA is the incident ray. OA is the incident ray. And this AB is the refracted ray. So AB is called as refracted ray. BC is called as emergent ray. Emergent ray. Okay. So there is a shift between the incident ray and the emergent ray. That shift is called as a lateral shift. Okay. Now that lateral shift we need to find out now here. So in this case, now look at now what we can do here. This is the angle of incidence, which is I. I is the angle of incidence. Now this is the angle of refraction. This is R. Now can you tell me how much this angle now? This is the deviation now. How much this value? How much this value? This is a deviation, right? So this is nothing but what we can say now, I minus R. I minus R. Now, so this distance means this is a perpendicular distance only. So I'm drawing one lines. This line. This we need to find out now. This one and this one both are same only now. So this is a lateral shift. This we need to find out. And if I call this point is something D, if I say. Now look at now triangle. Here this is BD is a perpendicular line, and here this angle is 90 degrees. Okay, if you draw this triangle separately, you can see now this is A and this is B and this is D. Here this is a perpendicular 90 degrees, and here we can see now this angle. This angle is I minus R. How much this angle here it is a I minus R, and the BD, B to D. This is the lateral shift. We need this one. Okay. Now let's get now if we apply the sine angle. Tell me now sine of I minus R equal to what? You tell me now. Sine I minus R, which is equal to what? Tell me now. Delta by AB. So from this lateral shift delta, which will be equal to AB into sine I minus R, isn't it? Sine I minus R. Understood this point? Hmm? Now we need to get this AB also. Tell me how we'll get this AB. How we'll get this AB now? And we are extending this normal to down exactly like this. Now you can see now here this angle is how much now? 90. This angle 90. Now we know this A to B. This length we know this value T na. This is, let us say this point is, if I say AE distance we know now. Now can I get the AB now from the triangle? From the triangle, can you tell me now sin R? So no, cos R will take, isn't it? Here the triangle, which is like this now.
Yes.
So here this is A and this is E and this point is B. Now this angle is R, right? So this A2 is a T, right? So we need AB, we need now. So we can take cos angle, that is cos what cos R, that cos R value will place here now. Yes, AB value here. Then from place of AB, we can place T by cos R. Yeah, this is the one standard formula. If you remember the formula, fine. Even without formula also, we can able to solve the given numericals. Okay.
Okay. For 2 minutes. That's
Right. So the next apparent. What is this apparent means? So you might be aware. For example, let us say we have taken a coin under a water in bucket. So a coin is placed with some object. Now, when you observe from the top view, the coin appears at some other location. Have you heard of this coin?
yes, sir.
Yeah. So that means what does mean of here? Why it will appear like that coin actual location is different and appearing location is different. When you are trying to catch the coin, so we are not able to exactly we may not get. That is because of the bending, the light ray will bend, so the light ray, because of that coin will appear at some other location. Yes, that is called apparent depth. So, to understand, let us say here, we have two mediums are there. Here Now look at now here the person is object here this light ray. Then now the light ray moving from where to where now? Denser to very medium. So then how the light ray will move now? Back towards away. Normal na?
Yes.
Light ray will move like this. Normal. This light ray which is coming. Understood?
Yes, sir.
This is called as a apparent depth. This situation. So actually, but here and this I'm calling and this apparent depth which will be same medium will appear at the same location. There is no problem. But if the object is one medium and the observer is some other way, then only we have problem. Then apparent depth. OPS in apparent depth which is given as mu observer refractive index of observer into real depth by refractive index of object.
Yes, sir.
Take this problem. To immiscible liquid. Immiscible liquid is a liquid which cannot be mixed together. Those two liquids are always separated. Two immiscible liquids are refractive indices given 8 by 1, 3 by 2 respectively are to take bigger as shown. The height of each coil is given 6 centimeters. The coil normal vision, the apparent depth of the coil is. We need to find the apparent depth, we need to find. Yeah, okay, now apparent depth. Apparent depth. So here we have two mediums are there. We need to continue here. First, here observer is take it as A. So refractive. Now we next here. Actual distance is how much now? 6 centimeters. Okay. Understood this step?
Yes, sir.
Next. Now here, this is how much?
Yes, sir. Yes.
Okay. By 4 now. So 16.
31 by 4.
Yes.
Okay, sir.
Understood.
Yes, sir.
Now you try to complete the remaining problems also.